Hello everyone, welcome back to this Siemens S210 servo drive and the motion control series video. And in this video, we will discuss the torque limits, or we call it torque reduction control. And if you recall, in my channel, I used the S120, the high-end servo drive, to show the torque limits or torque reduction control before. If you go to my channel and go to the playlist and find out the motion control, and click the right side motion control playlist, and then scroll down, let's find the Siemens S120 number 9, this MS06H, torque limitation and torque reduction. Okay, and in this video, when I discuss this torque limitation, and in the S120 series video, I used torque limiting, this function block, to show the torque limiting and reduction control. In this video, I will use the TorqueRange, this function block, to show how can we implement the TorqueRange control. To limit the torque, both function blocks can work for this purpose. And in this video, I will compare this TorqueRange and the TorqueLimiting. And I will show while I'm using this TorqueRange, and there will be a slight issue, and we can definitely solve that. And I will show the difference between these two methods. The torque limitation or torque reduction is a very common function while it's doing the rewind or unwind application. Okay, so let me show how can we do this. Firstly, we need to enable the Telegram 750. Okay, let's go back to the TIA portal and let's go to the drive, the Telegram. So I will use the drive red as an example. Double click and go to the Perfect port, and let's go to the Telegram configuration and drive Telegram. Okay, default while we are doing the positioning control, the Telegram is 105, and then to implement the torque limitation, so we need to add the Telegram. Once we click here, it will show this drop list. So we need to add this. So supplementary torque telegram. All right, so we add this torque telegram. We will see for the actual feedback, it reading one word. That's because this is reading the torque value. And the receive torque set point, that means from the PLC to the drive. The reason why it needs 3 words, we definitely need the upper and the lower limits, right? After we add this telegram here, then let's go back to the TO. Find out this red TO for this drive. Double click the configuration for the red motor, and then let's go to the data exchange with the drive. So default that's a Telegram 105, but if we scroll down, we will find here additional data. Okay, so we need to activate this torque data. And because we config the drive side hardware configuration at first, then when we click here, we will find the drive. Under the drive, it only search this additional Telegram 750. Okay, 750 here. Let's click OK. Wait for a couple of seconds. Okay, so the system add this Telegram 750. Okay, so make sure your hardware configuration at first, then come to the TO. For the comparison, if we go to the blue, synchronize this TO, and we haven't configured any Telegram 750 for the blue drive yet. So if we go to the configuration, we'll see the difference. So let's go to the data exchange and then find out this drive. So now if I activate this torque data, so we'll see the system cannot find the Telegram anymore because we haven't go to the hardware drive and config that 750 Telegram to the Perfect port yet. Okay, so this is different. Okay. So some cases, some new learner, they try to activate the torque data at here, then they cannot find anything. They cannot set up the connection. That's because you need to go to the drive configuration, find out the correct drive, go to the Perfect and find out this communication protocol, this Telegram, add this 750 at here. This you need to do the first. Okay. Then let's go back to the TO again. At this red drive, this TO, I add this torque value. Then let's go to another option, just to have a quick view. That is the torque limits. Okay, so by default, maybe your system shows on the low side, depends on you are doing the rotary or linear. Personally, I recommend you should select the motor side. The motor side, that's because while you are doing the mechanics setting, so some cases maybe your gear, most of cases your gearbox will not be the 1/1, that ratio. Probably you have a 20/1 or 40/1, the ratio. Depends on your gearbox you are using. But if you select this torque limits on the low side, then the torque limiting value will be limit at the low side. But in case one day you change the gearbox and you forget this setting, you will find your drive cannot deliver the high torque anymore, or maybe the torque limiting cannot work properly anymore. That's because you will find your mechanical setting wasn't got updated yet. So this will be a little bit annoying. Personally, I would recommend you select the motor side. And when we limit the torque value always represent the motor side. So you can do a very simple calculation. You can involve your limiting value, upper and lower limits, involve the gearbox calculation. This is the motor side. And then also the torque limits. This is the default value. In case the limitation we set at -0, then the system will leave a default torque limiting, basically kill the torque delivered power from the motor side. So we can leave a 0 at here. So again, motor side and a 0. And here, there's one option you need to be very carefully that I highly recommend select this as a default. This is the default selection, disable precision relative the monitoring. That's because when the system we are running the positioning closed loop, if we limit the torque, some cases you will find if your load is heavy, then the motor cannot deliver the enough torque because it's limited. Then the motor will be stuck or jammed there because it doesn't have enough force to push the load. However, the internal positioning closed loop, the set point still keep going, but your feedback basically is stuck there. Then the closed loop will find there's one huge difference between the set point and the feedback. Then the system will feel very confused. If you turn on the monitor, then the system will show the error, will basically stop the drive. Most of cases, we do not want to see this because we limit the torque in purpose. But if your drive has an error, then basically your production line will be stopped, right? This is something wrong, something not happy. So basically, we want to disable the monitoring, even we limit the precision loop. This is the highly recommend, disable the monitor. And then let's go to the programming. In Siemens side, all the torque limits is based on the new meter. Here is a new meter. I'm preparing this UDT for the dB, the data variable we will use. For some other motion control system, some cases they are limiting the torque based on the percent value. Okay, so this is a different system doing the slightly different way. In Siemens, they always based on the real torque value, new meter. Okay, and also we can add one torque enable signal. We can add here enable torque reduction. All right, we add those variables in this UDT, and then we can go back to the dB. The dB I created into the dB20 and update this UDT. Update. Okay, and then we'll find in this dB here we have this enable tag reduction and limits and this actual torque. Okay, then let's go back to the FC100. In the previous video, I introduced how can we program the MC function block power, hot, and relative move. Right? Okay. And here I can add the reading torque and we can limit the torque. So firstly, I can program, we can read the actual torque value. Drag the move command. Okay, and drag this axis. Drag this axis here, and then we can add this dot, find this status torque data, okay? And we can see this is the actual torque. Okay, this is the full name of this tag from this TO, okay? And then the right side, we can open this DB, float it, and drag to the right side. This is the actual torque value, okay? That directly represents the new meter. The new meter that actually comes from the configuration from the TO. If we go to the basic parameter, so you can see the measured torque. So it's based on the new meter we set here. New meter is a quite common way to show the torque value, okay? All right, this is the actual torque. Then we can program something to limit the torque. So we can find the technology, the function block, TorqueRange. So drag to here. And a single instant. This is the IDB underscore, and this is the red motor. Okay, red. Okay, click OK. Then this instant DB, go to the system block. Okay, this is the instant DB at here. Okay, IDB. So which access this TorqueRange will work for. So we will drag this red motor, this TO. Okay, drag to here. And the enable signal, we can drag it to drag this enable torque reduction, okay? And the upper and the lower limit, we can drag the upper limit and the lower limit, okay? So now we finish this connection, and now we can download the system and we can implement. Okay, after we download, and again, I like to quickly review the online help. So we can click the function plus F1, and let's quickly review the online help. And we can see this MC TorqueRange is used to limit the torque. So it has high and low limit here. And one more thing I like to notice here is, so once we turn on this torque limits, this function, once it's active, so the following monitoring will be disabled. Okay, this is the by default. This following arrow monitoring and the time limits monitoring. So what does it mean of this? So if we quickly recall, if we go back to the TO, when we set up the TO, if we double click this red master, go to the configuration. And since once we limit the torque, some cases maybe the motor will be jammed because the torque is not strong enough. Then the motor will stop, or basically slower than it's supposed to be. Then sometimes if we still enable the monitoring, then the drive will show the error, especially the TO, the logic wise will show the error. Then once we use this function, we need to disable the closed loop monitoring. So the closed loop monitoring comes from this positioning monitoring. So especially for this falling arrow, okay? Especially for this falling arrow. And now we can enable this. We can enable this following arrow, especially try this function, okay? And then I can download this. Okay, so now I enable this following arrow. Again, this is the online help of this TorqueRange. Okay, so now I have two different limits at here. One is for the positive, one is for the negative. Okay, and also notice here, this function block is very smart. So if in case you backward the limits, it can automatically correct this positive and negative, this sign. So it can automatically correct that. But still, you better notice the upper need to be the positive and the lower need to be the negative value. Okay, and let's go back to the program again. And now let's go online. Currently, we can limit this range to a smaller value, for example, 0.05. Okay, and the negative I can set different, minus 0.03. Okay, and temporarily I will leave this disabled. And once the drive start, we can enable that. Okay, and now I can power up. All right, now I'm going to power up this axis. Okay, power up. And now let's go to the velocity. And before I fire up, I especially want to bring up one input here for this position controlled. By default, this position controlled is true. If you haven't programmed anything here, I especially prepare this bool right here. By default, this input is true. So I will first leave this true as a default, and let me show what will be from the drive. Okay, so now I will fire this velocity, but now it is running closed loop, this position controlled. Okay, now the drive is started, it's spinning. And then let's go to the torque range. And we can firstly watch this actual torque. So it's running the positive direction 0.01. And I set this 0.05 range. Okay, I'll make that smaller, 90. So we can watch this torque value at here. Okay, I set this 0.05. Okay. Now, if I try to hold the motor, I haven't enabled that. So if I try to block the motor should fire with my load, and I can feel that torque is actually very strong. So now I'm trying to block it. Okay, I can feel it's very strong. Basically, it's really hard to stop it because now this motor is running 100% torque. And now I will enable it. Okay, now once I apply the load, let's see what will be. Okay. Okay, I will apply a load. Okay, I can see once I hold it, it stopped. Okay, let me try again. So let me reset this fault. Okay, it powered up again. And let me fire this speed again. Fired up. Okay, with this closed loop run. And enable this torque range. Okay, now let me apply. Okay, once I apply load, we will see the drive actually has a fault. Let's go to the start drive. Let's see what's going on from the drive. Double click this online diagnostic. All right, then let's go to this active alarms. The alarm is showing 7900. It's showing motor blocked, speed control at its limit. This alarm is showing correct info. However, while we're applying this torque reduction, actually this fault will cause trouble, right? If you try to stop the motor, which is totally fine, so you can use this torque range and stop the motor once the torque reaches this limit. However, in most of cases, we do not like this case because we like the motor keep running. Maybe if you apply the higher workload on this motor, the motor just jam here. It doesn't want to go, but the motor should now show the alarm. So how can we solve this? If we go back to the Siemens S210, this operation instructions, this manual, it has 800 pages. And if we search this arrow, okay, F07900, and we can see this is the motor blocked speed controller at its limit. And how to solve this, the remedy. Firstly, we need to check the torque limits. Okay, because we are applying this torque limits, this totally makes sense. And then let's check out this. Check the parameter of this motor blocked signal and possibly correct P2175. This is the key reason. And then let's find P2175. Okay, once we go to this P2175, we can see if this value is set to 0, then we can disable this alarm. So if the motor speed is less than the threshold or longer than 200 milliseconds, then the motor is shut down and a fault is output. Actually, while we're applying the torque reduction, we do not like this alarm, so we better set to 0. And meantime, we also need to check the parameter for the R1538 and the 1539 to verify if this torque limits set correctly to the drive. Okay, let's go to find these 3 parameters. Then let's go to the parameterization and find this parameter wheel. And if we firstly go to the R1538, okay, we can see the setting 0.05 and the negative 0.03. Okay, this is correct. That means the command we set to the drive, they all correct. But we need to check the 2175 parameter. 2175, it is here. So we can see it is running the default value, which is very high. However, once we block the motor, it will trigger the fault. So we need to set to 0 while using the TorqueRange. Okay? And after we set this, we should click this copy RAM to ROM. And then we go offline. And don't forget, we need to right click, click the upload parameter. Don't forget this. I will also prepare this situation while using the TorqueLimit, that function block. So while using the TorqueLimit function block, actually we do not need to change this parameter. Okay, so I will change this parameter while online 0. Now it is working at 0. So I will show this case temporarily first. Okay, show for the TorqueRange. Okay, now I set this to 0. And then let's go back to again. I will acknowledge this fault. Okay, we can try again. All right, now let's restart this motor. So firstly, power up. Okay, reset the fault. Okay, now the motor power up. So I will trigger this motor velocity. And meantime, I leave this position controlled to true as a default. So let's fire. So now the motor is spinning, is running. And the same thing, we enable this TorqueRange and we can monitor this torque value. Okay, so now if I apply the load, let's see this time. Because now I disable the 2175. Okay, so we can see once I apply this load, it can jam this motor, but there's no any fault anymore. But we will see another scenario right here. Once I release, the motor runs super fast and then shows fault. What's going on here? So this because this is the velocity command. If we go back to the move velocity, the default, this position control, this is true. However, while using this TorqueRange and while doing the torque reduction control, this will cause the trouble. We need to turn this off. That's because while blocking the motor, the internal positioning loop still running. Once I release, then the feedback and the set point, they have a huge difference. Then the system will feel very confused and try to catch this set point. But while it's catching, the speed may be too fast, acceleration too fast, and then the motor or the mechanical things will not feel happy. So this is the really things you need to prevent. So while using the TorqueRange or TorqueLimit, take care, we need to turn off the move velocity. So basically while using the torque reduction control, most of cases, or 99% cases, we will use the move velocity, doing the velocity control. So we need to kill this position loop, turn this off, okay? And then let's try it again. So firstly, reset this fault. Okay, now there's no any fault. And I will trigger this move velocity, but this time I turn off this position control. Trigger again. Okay, motor spinning. And now I will block this motor and let's see. Ideally, once I block, the torque should show this 0.05. And once I release, the motor just start run. Okay. Block, hold. So we can see the torque is showing 0.05. It's at this limit. And once I release, it just runs freely. Okay, there's no any like a catch-up speed, running fly. Block, release, lock, release. Okay, so this is the actual function we like, especially for this torque reduction control. While we have a load, it can do the highest torque it can deliver. And once it releases, the motor just run. Okay? Then, if we backward direction, now I will firstly stop the motor. Let's halt the motor. And this time, then I will run a backward direction. So we'll still leave this precision control off. Okay? And I will set negative 1080. Okay? And then I will trigger again. So leave this precision control off. And now we can see while it's doing the backward direction, so this torque feedback is showing negative. And let's see, once I apply the load, this value should show 0.03 negative at here. Okay, so now I will apply. Apply, no any fault, it just jam there. Release, free run, no any fly. Apply. So we will see a getting this negative 0.03. Release. Okay, this is the negative. And if now I enable this torque range, if I change this value on the fly, so now I change to negative 0.07. And I should feel a stronger torque from the motor, negative 0.07. Okay? And let's see, this negative 0.07 should reach there. And I should feel stronger load from the motor. Okay? Now, apply. I can feel a slightly hard. But now if I jam the motor, it should show negative 0.07. Release. Okay, run normally. Apply. Release. I can feel this motor is much stronger. Apply. Release. Okay, so this is the torque range. It is working what we want. And again, so now this P2175 is set to 0. Okay. So at this case, I should write here this P2175 need to set to 0. Alright, while we're applying this torque range, I prepare one watch list. Let's look at this watch list. So this watch list, I'm monitoring those queue address. This queue address represents the Telegram 105 and the Telegram 750. So where I can find those address, firstly. So if we go back to the device configuration, and if we find the right drive, and if we go to the PerfectNet port, so we will see those address. So we applied this Telegram 105 and Telegram 750. So let's temporarily ignore this Telegram 30. This is some test I did after. Now this Telegram 105 is starting from this queue 256 and is using 10 words. And Telegram 750 is using 3 words starting from the queue 296. So if I open this watch list, so we can see I'm monitoring this Telegram 105 starting from the queue 256, starting from here. And I'm monitoring this starting from the queue 296, starting from here. The reason why I'm set up this monitoring, I like to show this case, the moment ride. This moment ride is the command for the torque limit. Okay, so now we are using the torque range. So once we enable or disable the torque range, the output on this moment ride is not working. The reason why I'm trying to monitor this is to try to compare with the torque range and the torque limits, these two different commands. And also we can monitor this upper and the lower limits. The reason why the motor drive can receive the upper and the lower torque limits value 0.3, 0.5, just because of this. But we can see the QW address, the value showing this while we're watching this decimal value. So what does it mean of this? So I like to quickly explain this. So firstly, let's watch this. So if I enable or disable, so we can see for using this TorqueRange, it doesn't change anything on this moment ride. Okay, because this moment ride only worked for the torque limit, that function block. Okay, disable or enable doesn't change anything here. And then let's look at this upper and the lower limits. Is working. So while we're applying the force, the upper and the lower, they are working the full range. The full range for this positive, for this upper is showing 16384. And the lower, this must be the negative value at here, is showing negative 16384. So if sometimes you find once you power up the motor and it's doing accidentally fly away, the reason that's because the lower this limit accidentally set to a positive value. Or some cases, if the positive, this upper limit is set to a negative value. Then if we apply the on, the enable this TorqueRange, we'll see this value. So what does it mean of this value? This is actually show a percentage value based on the full range. So let me explain. So now we're applying 0.05, right? So how to calculate this? So this calculation is working as this way. Let's use this upper limits as an example. So the value 1240, it actually its base is 16384. Then the result, so equal to this value over this value. Then it's getting this 0.075. So this is actually work as the 7.5% value. Okay. Then if this percent value multiply the full range new meter from the motor, this is the new meter. Okay, new meter. And then let's look at this equal. Is equal to this value multiply the motor full range. That's equal to the 0.499. So this is actually the 0.05. That's why this 0.05 eventually it can send to the drive. And from the drive R1538, you can see this upper range limits is actually showing the 0.05 new meter. New meter. Okay. So while we're watching those values at this QW address, its base is this. Behind is working for this percentage value. And while this percentage value sent to the motion drive inside, then it multiply the full range of this motor and eventually get this 0.05, this new meter, this unit. Okay, this is quickly verified from this Telegram 105 and the Telegram 1750. Then while we're using the torque limit, next step, we will see they will show slightly different. Okay, now I will delete this MC TorqueRange. Okay. And I will drag this TorqueLimiting. Okay, TorqueLimiting. And same thing, I will drag this TO and enable. I will use the same command. So go find this DB. That's a torque reduction. Enable. And here we will see the limits. The limit, it only has one limit. That means for the positive and the negative direction, they work on the same limit. Okay, so I can just pick this upper limit, or I can create a new one, the limits, and drag this torque limit, drag to here. And we will see this value default is equal to 0.5 here, new meter, okay? And the mode, this is 0. 0, that means we are doing the torque reduction function. Okay, and also I will show this case while we are using the torque limiting. This P2175, even this P2175 left as a default value, it doesn't cause any trouble on the drive fault. This is not the same as the TorqueRange function. The TorqueRange function, as I just showed, we need to set the P2175 to 0. But while we are using the torque limiting. So you can leave this P2175 as a default. Okay? And before we start testing, so let's quickly review the online help again for this torque limiting. Let's click this function F1. Okay, this is the online help of this torque limiting. And this function block, actually, this is the one common function block I will use. And if we scroll down, we can see this limit is work on the upper and the lower two limits at the same time. One is for the positive upper, one is for the lower, the negative. And if this value left as a default -1, then it's -1, this value will come from the TO. Okay? And also take care of this mode. This mode 0, that means the false torque limiting. This is the feature while testing. This is the default value. And if we set to 1, then it is using the fixed stop detection. Okay, so let's leave this default mode. And if we go back to the TO again, so firstly this mode left as a 0. And if we go to the TO again, if this limits value left as a -1, the default value, then the torque limiting this value will be used from this limits, this torque limits this value setting. Okay? And in the meantime, this follow arrow, everything left as a default and left as the positioning control. Okay? Now I can power up, monitor, and power up the drive. Alright, now we can see this torque value. We haven't powered up yet. So let me scroll up and power up this drive. Okay, before we start to run this motor, let's double check this parameter from this right drive. So if we go to the right drive parameterization, and let's check this P2175. Okay, this P2175 now is running as a default value. It's now 0. Okay, we are enable this feature, motor blocked speed threshold. Okay, and also from the TO, everything as a normal, like the monitoring, following arrow, all those monitoring are enabled. Okay, now I enable this drive and let's fire this move velocity. And in the meantime, let's watch out this. So I leave this command as true as a default, especially show this case. Now this closed loop still running as the positioning closed loop, even while firing this move velocity. Let's see if this is left as a true, so what will be. So let's fire it up. Now the speed is 1000 this speed, degree per second. Now the motor is running. And then let's scroll down. Okay. I am applying this 0.5 positive and negative, this new meter, this unit value. Okay, this value now I can set a range 0.05. Okay, 0.05 means the upper and the lower. The upper is 0.05 and the lower is a negative 0.05. Okay, and the current torque is running 0.01. Okay, and now if I apply a torque, okay, very strong. So that's because I haven't enabled that yet. And now if I enable, okay, now I enable this torque limiting, and let's see this time. Okay, let's see this time. Apply. I can stop the motor, and now all things are default and drive is still running without any fault. But motor jammed because I applied this load. Release. But after I release, you will see the drive run very fast and then fault. Okay? This is the same scenario as we are using the TorqueRange. That's because for this velocity, for the positioning control, we turn it on. And in the meantime, let's see the fault. Go to the online diagnostic and let's go to the active alarm. Okay, it's showing 7901, motor overspeed. And we can also change this P1082 for change this alarm threshold. But this is the case we do not like to see. Firstly, let's acknowledge this actually comes from the move velocity, that command. So let's go up. That actually comes from here, this position control. While we are using the torque reduction, and we fire the move velocity, so we need to turn this off. So kill the position closed loop. Because while we are jamming the motor, the internal set point is still working, but the feedback it actually stop and jammed there. And once I release, then the set point and the feedback, they will apply to a huge feedback to the positioning closed loop, right? Then the motor will run very fast. So while we are using the torque reduction, keep in mind we need to turn off this position control. So let's leave this off. Now I will fire it again. Okay, so let's firstly reset this motor fault. Okay, we reset, and then let's go back to this move velocity, and let me fire up this motor. Okay, it fired up. And then let's go back to the torque limiting. Okay, so this torque limiting is enabled, and the range is 0.05, and it's showing busy. And also let's watch this in climbing and in limitation. While I'm applying this load, so we will see this in limitation, and this torque value will get this range 0.05. All right, let me apply. Okay, apply. Okay, in limiting, and the highest torque is 0.05. Release. Apply. So while I'm applying load and while the motor is jammed, we will see the in limitation it turn on, and the torque value is 0.05. You get this highest range. Release. And after I release, we will see the motor can move smoothly. Doesn't show any fly again. Okay? Apply. Or I can apply. Release. Apply. Release. Apply. Release. Okay? So this is the torque reduction we like. So once we have a load, the motor just stop there, and once the load released, the motor can keep continuously. And now let's run the backward. Let's see this negative 0.05 still working or not. So let me firstly stop the motor. Hold the drive. And from this move velocity, I can set negative. Let's run faster. Negative 10. Let's run faster. Negative 1500. Okay. Fire. While it's running faster, we will see default. This torque will show a little bit higher. See here? Before it's below the 0.01. Now it's higher 0.01. Absolute value. Okay, now it's running backwards. That's why this shows negative value. And let's see if this negative value also works. Okay. All right. Apply the load. Okay, the motor stopped, and we can see the actual torque is a negative 0.05. Release. Apply. Hold a couple of seconds, and release. So we will see the motor just keep continuously without any fly issue, and the negative value also works. Okay, apply. 1, 2, 3, 4. Release. Okay, we will see the negative range still working. Okay. All right. to compare with torque limiting and torque range we just did before. So while we enable this, let's look at this watch list. Open the watch list, open this watch table, start monitoring. So we can see while we are using the Telegram 105 and this torque limiting, we can see this moment right, and it is working for this value. That's why this torque limiting is actually shows slightly easier, because it actually works something behind. Basically means it kill some feedback loop and kill some monitoring behind. And also we will see while we are using this torque limiting here, upper and lower limits actually is working the full range. That's because this range actually working behind where some protocol running inside. Okay? And if I disable, we will see this area totally changed. But this area doesn't change anything. Okay? Enable. It's working for something behind. And disable. Okay? You can see this area is changing. This is the difference between the torque limiting and the torque range. Torque range is working on here, but torque limiting is work on here. Okay, it's work on based on this Telegram 105. Enable, we will see this area is changing, but this area is not changing. But if we go to the drive, even here is not moving, not changing. So if we go to the drive, look at this parameter wheel. So if we go to the R1538 or 1539, actually this torque limiting, actually this effective torque limits is showing correct value. If I float, as we can see here, it actually working. So if I turn off, we will see it return to its full range, 0.66. This is the motor new meter full value. If I apply, then this value will work for this 0.05. If I change this value, change to 0.12, we will see positive and negative 0.12 is showing here. So it's still working. Even this QW is not working, it's not showing this changing. But this memory is working for this. Okay, this is the difference between the torque limiting and the torque range. I like to use this video to show these two different applications. Okay, this is a torque reduction function. Both ways you can use. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.